in number 5, we have an exponential decay problem. So we write down our basic formula, and we have that. It says that today we have 100 grams. So if we substitute in t equals 0, we're going to get that c is equal to 100. So let's just write that down. C is 100. And next it says 1/4 of the substance decays every 20 years. So that means in 20 years we're down to 75. 1/4 has decayed. 1/4 of 100 is 25. So 1/4 has decayed, so we're down to 75. So let's write that. Okay, so we have 20 years and we're down to 75. Now using this, we can figure out what K is. So let's do that. Let's figure out K. So let's divide both sides by 100, and we have 0.75 is equal to e to the k times 20, and then just take the log of both sides. Now divide by 20. Okay, we'll approximate what this is equal to using the calculator. And here's our approximate value for k. And now we want to know what happens when t equals 12, what's y equal to. So we just fill in t equals 12. So we have 100 e to the k times 12. And let's just approximate that. And we have approximately 84 grams. Okay, let's remember the arc length formula. Okay, that's our arc length formula, and so we're going to apply that to this arc, or this function, from 0 to 4. All right, so we have the integral from 0 to 4. Let's look at the derivative of this. Well, the derivative here, let me do that over here. Y prime is equal to 1/2 16 minus x squared minus 1/2 times negative 2x. So that's minus x over square root 16 minus x squared. All right, let's square that out and simplify. And we have x squared over 16 minus x squared. And now let's add these two. Let's write this as 16 minus x squared over itself. Okay, let's just add those together. And under the square root, we have 16 in the numerator. So what's that equal to? Square root of 16 is 4. Let's bring the 4 out in front. And we see we're left with an arc sine derivative. All right, so let's just evaluate this integral. Okay, this is from 0 to 4 again. So this is 4, and this is an arc sine. And so here we have arc sine x over a, or x over 4. And we are evaluating from 0 to 4. Okay, so let's do that. So we have 4 arcsine 1 minus 4 arcsine 0. This is 0. Arcsine of 1 is pi over 2. So let's multiply 4 times pi over 2, and we have 2 pi. Now, let's look at this original problem. This is a circle, radius 4, and we're looking at 1/4 of the circle. Now, the circumference of the circle is 2 pi r, but we're only looking at 1/4 of the circle. So we do expect to get 2 pi, which we did. In number 7, we have an ellipse with these foci and minor axis length 6, and we want to find the equation of the ellipse. Let's just draw a little picture. So the foci are 0, 3, and 4, 3. So let's put them here. This is 0, 3, 4, 3. They're lined up horizontally, so we have a horizontal ellipse. And in the middle, we have the point 2, 3. That's the center. The minor axis is length 6. I'm just going to draw the ellipse, just draw a picture of it. All right, the minor axis is length 6, so these are lengths 3 and 3. So we'll go up 3. So here we have the point 2, 6, and go down 3 from 2, 3. And here we have the point 2, 0. We want the equation of the ellipse, so we need to find this length over here. The equation of the ellipse, this is a horizontal ellipse again, will be x minus 2 squared over a squared, so it's a that we have to figure out, plus y minus 3 squared over b squared. Well, b we know, that's 3. That's because the minor axis is length 6. So we just have to figure out a. We have our little equation, c squared is equal to a squared minus b squared. C is this distance over here, which is 2. All right, so we have 4 is equal to a squared minus b squared is 9. So a squared is 13, and a is the square root of 13. All right, so a squared is 13, and that's the equation of our ellipse.